Now, when it comes to solving different equations, what we're effectively trying to do most of the time is we're trying to get our variable, in all of these cases x, by itself so that we have x is equal to something. Now to do so, you need to be able to basically remove every operation present that is not the one you're trying to isolate for. Now, looking at our order of operations here on the left-hand side, we do have many different operations, and we're going to talk briefly about how to remove most of them. For brackets and functions, this is actually left to its own module in this section, which you'll see later on when we talk about functions and inverse functions. However, exponents, division and multiplication, and addition and subtraction are all things that you should know how to get rid of. Now, the trick to getting rid of them is to recognize that for each operation, there is effectively an inverse operation that cancels out something. So, to illustrate this, we're going to look at each of these examples in order and talk about which operations are inverse to one another. Interestingly enough, these inverse operations are always ones that are at the same level of complexity. So we're going to start with addition and subtraction. If you take a look at addition and subtraction, they are the same order or the same level of complexity. And the reason they're grouped like this is because they are opposite operations to one another. So if you take a look at this associated equation here, x plus 5 is equal to 10. If your goal is to get x by itself, what you want to apply to both sides is the opposite operation of this addition by 5. Now, for this opposite operation, what you're going to add to both sides is a subtraction by 5. And what this is going to do is on the left-hand side, for this plus 5 we want to eliminate to get x by itself, it's actually going to cancel the operations out. And this is going to leave you with just x on the left-hand side. And on the other side, you can evaluate 10 minus 5. It's simply going to give you 5. And so what you'll notice there is if you want to eliminate addition, you can apply the exact same amount of subtraction to both sides of your equation. And you do have to apply these to both sides of your equation because this equal sign is telling you that the left and right hand sides are exactly the same. To keep them the same, whatever you do to one side, you have to do to another. Now, if you wanted to get rid of subtraction, the process is very similar. If you wanted to get rid of a subtraction by 5, you would simply use an addition by 5. Now, moving on, we can take a look at division and multiplication. Just like with addition and subtraction, these are opposite operations and they're on the same order. You can show that division and multiplication are the same through the use of fractions. Now, if you take a look at this particular example that we're dealing with, we have 2 multiplied by x is equal to 12. In order to solve our equations here, we're going to want to remove the multiplication by 2 on the left-hand side. This can be done by, again, dividing both of the entire sides by 2. And it's important here that you divide everything by 2. Now, just like with addition and subtraction, a multiplication of 2 and a division of 2 are going to cancel each other out. So on the left-hand side, this is just going to leave you with x. And on the right-hand side, 12 divided by 2 is just 6. Now, this last one here, exponents, you can get rid of these, and this is typically speaking what people have the most problem with. One of the things is exponents are their own inverse. Now, in order to apply an inverse exponent to eliminate, say for example this power of 0.5 that's on top of x, you want to use an exponent, but you want to use an inverse exponent. And how this generally speaking works is what you're going to want to do is you're going to want to take a look at the exponent that you want to get rid of, the 0.5 here, and to find the inverse exponent that you're going to want to apply to both sides, what you're going to do is you're going to take 1 and divide it by whatever exponent that you're getting rid of. 1 divided by 0.5 is just 2. So what this is telling you is in order to eliminate this exponent of 0.5, you're going to want to isolate the entire side and apply the inverse exponent of 2 to both sides. Now the nice thing about this is the 0.5 exponent and this 2 exponent are going to cancel each other out, and on the other side we'll just have 6 to the power of 2. So what you'll get here is once you've applied this, you'll get x is equal to 6 squared, no, 6 squared, which is just 36. Now, You might have seen this in some fashion. X to the power of 0.5 is actually just the square root of x. But this method here of finding the inverse exponent and applying it to both sides works for every single exponent, regardless if it's fractional power, a whole power, it doesn't matter. Take whatever exponent you're trying to get rid of, flip it around, and apply that inverse exponent to both sides. And it will remove it and leave you with just the variable.